Hi, Assalamualaikum. Now we reach at the second subtopic of roots of nonlinear equation, which is Newton-Raphson method. For Newton-Raphson method, it has a specific formula. You can see here it is xi plus 1 equal to xi minus fxi over f prime xi. So you can see that you have to do a little bit differentiation, you have to do actually you have to have a skill of differentiation here. Okay, usually if the question, if let's say in the this Newton-Raphson method is asked in the exam, usually the f prime is given for you, because we actually don't want to ask you how to do the differentiation, but we want to know how you know how to apply the Newton-Raphson method. All right, so this is the formula of Newton-Raphson method. So your aim, remember, is you want to know the value of x so that the fx equal to 0. All right. First example, use the Newton-Raphson method to estimate the root of fx equal to x squared plus 2x minus 5, accurate to epsilon 0.001. Okay, you are given epsilon 0.01 and given an initial point is x0 equal to 1. Okay, so you have the initial point here, used for decimal places in all calculation. If you still remember, in bisection method, the initial point given is in terms of interval. The Newton-Raphson, now for this question, you are given the initial value in terms of a value directly, a value. But the question also can give you an interval. So if let's say you are given in terms of interval, what you have to do is you have to apply intermediate value theorem to find the interval, or to find the value that which is suitable to find to be the initial value for Newton-Raphson. We will discuss it later on, no worry. Okay, so we have to make sure your calculation in 4 decimal places. All right. So first of all, you can see here, this is the formula of Newton-Raphson. In the formula, you have to do the differentiation. So of course, in your first step, for the first step, you have to differentiate the fx. So fx given in question is x squared plus 2x minus 5. So differentiate it, you will get 2x plus 2. Okay. The second step is you have to substitute the initial value given in the question, which is 1. Okay, initial value given in the question, substitute into the f prime, you will get 4. Okay. The reason why we have to substitute the initial value, because we want to make sure the initial value is suitable to be the initial value for the Newton-Raphson. You can see the formula here. We have f prime to be the denominator of the formula. If let's say that the denominator is equal to 0, so the calculation cannot be continued, because any number divided by 0, you will get infinity or math error. So what I want to say here is you have to make sure that this prime f prime x0, which is the initial value, cannot be equal to 0 or cannot be too close to 0. Otherwise, your calculation cannot be done. Okay? Alright. So now for this question, your initial point 1 is suitable to be the initial point for this problem, because when you substitute into f prime is equal to 4, which is okay lah, not so close to 0, and of course it's not equal to 0. Alright, now, so come out with a table. So in your table, you should have iteration as usual, and then xi, and then fxi, f prime xi. And this column, I will put the value of epsilon, where epsilon we can find by using xi minus with xi minus 1, absolute value. Xi, which is the current xi, minus with the previous xi. So that's how we find the value of epsilon. All right. So now the first point, the first iteration, which is iteration 0, it is 1, x0, it is 1 because we have in the question that x0 is equal to 1. Okay, so x0 equals 1. So now substitute 1 into fx given in the question. Okay, so you will get value -2. Okay, substitute 1 into the fx, you get -2. And then this one you base on the f prime that you obtained before. Okay, so you substitute the initial point x0 into the f prime, you get 4. And this one you don't have to substitute. You have to, for the epsilon value, no value yet because we don't have any value any value before the x0. You got my point, right? Okay, now continue to iteration 1. Okay, now iteration number 1. So use the formula given. Okay, use the formula given. The formula of Raphson. Okay, to find the x1, you have to use the previous x, which is x0, minus fx0 divided by f prime x0. So substitute into the formula, you get 1.5. Then 1.5 substitute into fx, you get 0.25, and then the same value, which is x1, substitute into f prime, you get 5, and then find the value of of epsilon, where 1.5 minus with 1. Okay, so I got 0.5. So this is 0.5. So the calculation has to be continued because the epsilon is not 0.001. So the epsilon value has to be based on the stated epsilon given in the question. So continue to iteration number 2. Iteration number 2, you find x2, you use the previous value and then substitute into the formula. Make sure you're not careless, okay? In numerical, the solution is very easy to do, but you have to be very careful because if you substitute the wrong value, so it will affect the rest of your solution. Okay, be careful. Then you substitute into fx, find fx. 2, fx2 to find the f prime x2 as usual, and then you find the epsilon where 1.45 minus 1.5, which is the previous x, so you get 0.05. So this is still not equal or not less than 0.01, so you continue to iteration number 3. Iteration number 3, so you use the previous value, which is 1.45, and so on and so forth. Substitute into the formula. Okay, this is so easy. Okay, and then you calculate the value of epsilon, which is 1.495 minus 1.45, and we get 0.0005, which is actually less than 0.001 given in the question. So now you can stop your calculation because the epsilon value is already less than 0.01 as stated in the question. So your answer is this one. This is the answer. Okay? Alright. Question number 2. Example 2. Solve x cubed minus 3x minus 1 using the Raphson method with initial value x0 equal to 0. Use 6 decimal places. So now for this question, your initial value is x0 equal to 0. So you have to follow this, but no epsilon value is given. So it means that you don't have to follow, you don't have to base on the stopping criteria in order to stop the iteration. So what you have to do is, so first of all, of course, you have to differentiate it. Okay, differentiate the fx, you will get 3x squared minus 3, and then substitute the x0, which is 0, you will get -3. So -3 is okay, means that not close to 0 and not equal to 0. So means that this x0 equal to 0 is suitable to be the initial value for this solution, for this problem. Alright, now continue to come out with a table. So iteration xi, fxi, and this one f prime xi. Okay, So for iteration 0, xi is equal to 0 based on the question, based on the given initial value. Okay, so fxi, how to calculate fxi? You substitute into the fx, so 0 cubed minus 3 multiply with 0 minus 1, so you get negative 1, and then 0 substitute into f prime, so 3 times 0 squared minus 3, so you get negative 3. Alright, now continue iteration 1. Okay, for iteration number 1, you want to know x1, so it is 0 minus negative 1 divided by negative 3. So you will get negative 0.333333 because the question asks you to use 6 decimal places. So my answer should be in 6 decimal places. Now substitute into the fx, okay? Substitute into x cubed minus 3x minus 1, substitute the x. So negative 0.333333 cubed minus 3, negative 0.333333 minus 1, you will get negative 0.037037. Okay, then you do the same thing, substitute x0 into f prime, you will get negative 2.666667. Okay, and then you have to continue again more for iteration number 2, do the same thing, the same process, but based on the previous value, you will get negative 0.347222. Okay, substitute negative 347 into the fx, you get negative 0.000196, and then substitute into f prime, you get negative 2.638310. You just based on the x given that you obtained. So when you have to stop, okay, just continue the process. Don't worry, class. Okay, and now you get negative 0.347296. Use the formula of Raphson. You get this value, and you substitute negative 0.347296 into fx. You get 0.000000. Now you can stop because you already reached the solution. Okay, so this is the answer that you want. This is the answer. Okay, if you still want to continue, believe me, if let's say you want to try, you confused whether you can stop or not, you can continue, don't worry. But you will get the same solution. Means that you already converged to the solution. Okay, all right. Let's proceed to the next example. Okay, this example, solve x squared minus 4x plus 4 using the Raphson with initial value x0 equal to 2. So I differentiate the fx, I got 2x minus 4. And then I substitute the initial value 2, and suddenly I got 0. So means that if let's say I want to do I want to proceed it, I, xi, fxi, okay, f prime xi, okay, I will do iteration 0, xi is equal to 2, x0 equal to 2, fx0 is 2 squared minus 2 squared 4, which is 4 minus 8 plus 4. I got 0, okay, and this is also 0, okay. Let's say I continue to iteration number 1. What happened here is your calculator will give math error because a number divided by 0, 0 divided by 0 is math error, no answer. So means that what I want to say here, if your f prime is equal to 0, so don't continue your solution. You just can say that the initial value is not suitable for this problem, for this fx. Okay, all right. Next, okay, how about if, okay, I take the example number 2, same question, but now with the initial value 0.99. Okay, as usual, we differentiate it. I get 3x minus 3, and then I substitute 0.99. I get negative 0.0597. But I don't know whether this value is suitable or not. This value is close to 0 or not. No worry, just continue it. Okay, let's say you already continue. Okay, come up with a table. So your iteration at iteration 0, x0 is 0.99 based on the question. Substitute into the fx, you get negative 2.999 and f prime is 0.0597. And you continue, you will get negative 49, which is big number, okay? And then you continue, fx is negative 1.99. If you continue, you will get bigger and bigger number, which is actually not suitable as well. Okay, so we consider this value is close to 0. And it is not suitable. And what I mean here, the initial value is not suitable to be the negative 0.99 is not suitable to be the initial value. Okay, I hope you got my point. Okay, don't worry, do exercise, inshallah, you can increase your understanding. Okay, that's all.